We're Team 1, and I'm Rafael Serrano Campos.
Eric Guardado. Juan Carlos González.
Zero, read the problem. Step 1, sketch the problem.
Step 2, gather the data. Step 3, use the formula to set variables and clear if necessary.
Step 4, substitute the data in the formulas. Step 5, write the answer with the correct unit.
A ball of a mass of 2 kilograms be released from a point A and is lying in the friction track as shown in the figure. The heat of A is 8 meters. Determine the beat speed of the points B and C, and determine the net work done by the force of gravity moving the debris from A to C.
So first we take the segment A to B, and we have the kinetic energy in the highest point, that is 0 because there's no movement, and we don't know the potential energy. So we use the formula potential energy equal to mass times gravity times height, and we multiply. We have the mass, that is 2 kilograms, the gravity, that is 9.8 meters over second square, times the height, that is 8 meters, and we multiply and we get 156.8 joules. And now here we have that the potential energy is 0 because this is the lowest point, and the potential energy and kinetic energy, the value is changed. And now in the point B we have that is 3.2 meters, and we apply the same formula, and we get 62.72. Now we have the potential energy of the point A, and we subtract to the potential energy of the point B, and we get 94.08 joules. And now we use the formula of the kinetic energy, and we clear to get the velocity, and we get that. And now we substitute the values, and now we solve, and we get 9.7 meters over second square. In the last part of the problem, we take the last segment, B through C, and as we know, the kinetic energy is 0, and the potential energy is 62.72 joules. The height of B is 3.2, and the height of C is 2 meters. As we know, the kinetic energy is 156.8 joules because it is the same as the other segment that we explained. And we calculate the potential energy multiplying by the mass, by the gravity, and by the heat, and we give us a result of 39.2 joules. And with that, we want to know the velocity, so we substitute with the formula of the kinetic energy, and it gives us a result of 6.24 meters over second square.
Okay, now we're gonna solve the problem, the segment B.
So we're gonna use this formula. It's work, it's equal to mass per gravity times the height of A, subtracting the height of C. That's gonna give us 6. And then we're gonna multiply everything, and that's gonna give us a total work of 117.6 joules.
Make it clap, clap, clap. Damn, baby, you got a bright future behind you.
The first thing to know is that the roller coaster stands 415 feet high. The kinetic energy is equal to 0 because the object is moving. The potential energy, we're gonna solve it with the formula that we already explained. It's gonna be the mass, we get it from the car capacity. There's 14 riders, so we're gonna say that the average weight per person is 75 kilograms. So we multiply those and we get 1,200 kilograms, and then we're gonna multiply that by 9.8 meters over second, which is our gravity, and then times 415 feet, which is our height. We're gonna get 4,880,400 joules. Okay, so now that we have our potential energy, we're gonna solve for our middle velocity, which is, we're just gonna take the middle height, which is gonna be 207.5 feet, and we're basically gonna solve in the same way for our PE, and the PE is gonna be the same as the kinetic energy. So we already know that our potential energy is gonna be 1,440,200, and then we're gonna solve for our velocity with the formula of kinetic energy is equal to 1/2 times mass times velocity squared, and we solve for velocity. That's gonna give us the middle velocity of 63.8 meters over second. Okay, now that we have our first velocity, we're gonna get the last velocity, the final velocity. We know here that our potential energy is gonna be equal to 0 because the car is gonna stop at some point, and our kinetic energy is gonna be the first, the total energy we had in the ride. So we're gonna do the same thing again with velocity, and we're just gonna use the kinetic energy from our whole ride joules. So now we do the same thing, we solve, and then we get 90.2 meters over second for the final velocity.